So let's start with question number 2. Now question number 2, these kind of moves we have seen several times in several problems, like a plus b by 2, two numbers getting erased and we get a plus b by 2 instead of those two numbers. We have seen questions where sum of all numbers has been asked, or we attack on parity of the numbers, whether numbers are even or odd. So we work on invariance and these kinds of things, right? So when we see this question on the first side, it looks like it could be one of those problems. The difficult part of this problem is that in the beginning numbers, say we start with 3 numbers, we get 2 identical numbers, so we cannot move ahead. And yes, that was a problem in the question. Some of the students said that they thought that in case they are getting 2 and 2 as the same number, it's one number. But obviously example itself shows that they are 2 identical numbers and we cannot move ahead. Note clearly says that. So we shouldn't have thought that. Anyways, taking more examples, we could have seen that we converge to a final number. So obviously that has to be the question. Anyways, coming back to the question. So if I take 1, 2, 3, the final result is 2 and 2. So this cannot work. Finally, we need just one number. And the question says we have to add 2 numbers and find the average of those 2 numbers. And we have to keep doing that. But we cannot take 2 identical numbers to find the average. So finally, can we reach to a single number or not? This is the question. Alright, finally, can we reach to a single number or not? Starting from 1, 2, 3 till n. So if I take 1, 2, 3, 4, obviously I have to take for 1, 3 and 2 and 4. Okay? And you might have noticed that for every question what we are doing is we are working on examples. Because working through examples, we can find pattern in the question and from there we can judge what kind of question is there. And sometimes we directly attack the problem as well. No? But for these questions, what most of the students did and what I did was going through example. So if we start with 1, 2, 3 and 4, we'll obviously take 2 and 4 and 1 and 3, or we could take other combination as well, but we'll end up with 2 and 3 only, either ways. So using all the ways, we do not get a final solution here. In case we take 1, 2, 3, 4, 5, there we can see that using one way or other, we are converging to a number, which is 3. Alright. So what we have seen here is that we converge here for n equal to 5, but we do not converge here for n equal to 3 and 4. That we do not get a final single number that has been asked in the question. So our intuition is the answer could be 4k plus 1, or it could be 2 to the power k plus 1, just because we have seen some previous question. But anyways, the obvious thing to do is move ahead with n equal to 6, 7 and 8 and see what kind of pattern is being followed there. So we try for other numbers, 6, 7, 8 and so on and so forth, and then obviously we get to a pattern. And as you try, you'd see that there could be multiple variety of solution for this question. We can show it mod 3, we can show this solution to this question mod 4, mod 2, whatever, like these ways, in the sense that we can attack on the final solution with respect to different variety of numbers, right? So here what I will show that there is a standard solution for most of the numbers. That is what I am going to show here. I'll show with example. I'll take 1, 2, 3, 4, 5, 6, 7, 8 and I will show for 1, 2, 3, 4, 5, 6, 7, right? Suppose I take this number, I can delete these two and make another 7 here. Obviously, I cannot take average of 7 and 7 because the two numbers cannot be identical. Now, what I get here is 1, 2, 3, 4, 5, 7, right? And another 7. Let us assume here also I keep 1, 2, 3, 4, 5, 7. Another number is 6. Alright, now 5 and 7 will give me 6, 4 and 6 will give me 5, 3 and 5, sum is 8, so it will give me 4, 2 and 4, sum is 6, so that will give me 3. Anyways, the numbers that remain are 1, 3 and 7. Okay, the numbers that remain here are 1, 3 and 7. Similarly, say I move with here also 5 and 7, 5, 6, 7, right? 5 and 7 will give me a 6, 6 and 4 will give me a 5, 5 and 3 will give me a 4, 4 and 2 will give me a 3. So the numbers that remain here are 1, 3 and 6. Alright. Now, both of these are quite similar in the sense that we'll end up with 1, 3 and one other number say 7. Here we'll end up with 1, 3 and another number say 6. In this one, it's pretty obvious. These two are odd. So if I add these two, I'll get 3 plus 1, 4. 4 upon 2 is 2 and 2 and 6 will get a final number, right? Final number is 8 upon 2 is 4. So we'll definitely converge. In this one, 1, 3 and 7, we'll have to just look at the variety of the numbers. Alright. We'll just have to look at the variety of the numbers. This is 4k plus 1, this is 4k minus 1, this is 4k minus 1. So whenever we have these numbers, we'll have 1, 3 and maybe some other variety of numbers. So in this case, what we'll do, we'll take 3 and 7, 10, their middle is 5, 1 and 5, their middle comes out to be 3. So we converge to a final number. If it be 1, 3 and say 9, say this number where 1, 3 and 9, because it will converge in a similar manner, then in that case what we could have done is, we could have taken 1 and 9, right? This would have given me 5, 5 and 3, this would have given me 4. So just that combination is necessary because 1 and 3 are different mod 4. This is 4k plus 1, this is 4k plus 3. So which number has to be combined from here will matter depending upon the variety of this number. This is 4k plus 3. So 4k plus 3 will combine with 4k plus will combine with this 3 number 4k plus 3 so to give me a 5 or something. So you mostly understand what is happening here. So in both the cases we are able to converge and that gives us a final solution. But for smaller numbers we can show by taking all possible cases that such a solution is not possible, and for number 5, 7 and so on and so forth, all the numbers greater than 7, we can easily show that this works. Alright, so that solution will be outlined by different students here. So for that purpose, I invite Swarit on board for his solution and his this one for his solution. But yes, the solution given by different students could vary. This is the simplest form of the solution that I could come up with.
It's already given to us that we can't do this because we will reach 2 and then we can't proceed. And then we juggle through some more cases to try for which n it will be possible and for which it won't be. So once we try n equal to 4, then it is easy to see that it won't be possible. We eventually reach 2, 3. Then we try n equal to 5. And then after trying for some time, you can actually get that n, we can reach a single number in the case of n equal to 5 by, if you take 2 and 4, then you can get this, and from this 2, 4, and we can reach 3. But now we can also observe that this is a very systematic way which we can follow for all the odd numbers. Like we started with 2 and 4, which was next to 3, that was the middle number. So that now we can get to these two groups. So like if n was 7, then you can take 3 and 5 and make it a 4, so that now we have 1 to 4 and 4, 6, 7. Now this is very good actually because once we take 2 and 4, then we get a 3, which is again difference 2 with 1. Reduce this to 2, and similarly here we can, this is almost symmetric only, so 5, 7, and then we can get 6 and then 4, and now these two will be even. We can easily see that because we have taken n odd. Since if n is odd, we have n is equal to, let's say, 2x plus 1. If n is 2x plus 1, so the middle number will be x plus 1, and here we have x plus 2 till 2x, 2x plus 1. and we can make this another x plus 1. So we have x minus 1 and an x plus 1 here. We separate into these two groups like x plus 2 is gone, so we have 2x plus 1. Now the thing is that once we take the last two terms here, we get another term that is like x, which is again difference 2. Like x minus 2 will be the last term now, so the difference is still 2, so we can keep on doing this till we get 1 3 and then we get 2. Similarly here we can take the first two terms again and again till we get 2x. So now we have 2 and 2x and we can reduce this to 1 number easily. So once we see that this is done for n equal to odd, we start to see for n equal to even numbers. So we see that n is equal to 4 is not working, then we see n is equal to 6, we try and get to one number, but after some time, take 5-10 minutes, it's not working out. So it seems like then even will not work, but of course before we start to try proving that n equal to even won't work, we should also check n equal to 8. Because if we are what we are trying to prove is wrong, then we are just wasting our time. So we can try for n equal to 8, but after some time juggle through the things and get that if you can get 6 and 8 to become 7, and then again apply something similar, that is like a difference 2, we can get it to 6, then again there is a difference 2, we can get it to a 5, and then we can eventually reach 1 3 and the number here, that is if we started at n equal to 2x and here will be left with 2x minus 1. So 1 3 and 2x minus 1. Now the great thing is that we have 1 and 3 with us, so if we have to consider two numbers that are like if we can take 1 and 2x minus 1 and the number that we get after it after doing this operation is odd, then we are good. Or if we can take 3 and 2x minus 1 and the number we get afterwards is odd, then also we are good. So the great thing is that we want the two numbers ka sum should be 0 not 4, and we can set it so that it happens because we have 1 and 3 both with us. So essentially if x was like odd or even, you can take the two cases here like 1 3 and 2x minus 1 we have. So n was actually 2x. So now we are only seeing that if x is, we have two cases, x is 2l plus 1 or x is 2l. So if x is 2l, so essentially we have 4l minus 1 here. But now we just want the sum of one of the two sums to be divisible by 4. So we can take 1 and 4l.
No, not to be divisible by 4.
नहीं, two numbers we want कि जिनका sum हो जाए
2 mod 4.
2 mod 4.
Yeah, sorry,
Yes,
yeah,
2 mod 4.
2 mod
Yes.
4 हो जाए. Yes, of course, sorry. 1 and 4l minus 1, 3 and 4l minus 1. So इनका sum है 2 mod 4. So जो इनका operation होगा, we will get 4l plus 2, 12 plus 1. So we have two odd numbers and we can easily reduce to one number. And similarly, if we have x is equal to 12 plus 1, so we have 2 times 12 plus 1, 4l minus 1, sorry, 4l plus 1, yeah. And then 1 and 3. So we can take 1 and 4l plus 1, so that our sum is 2 mod 4, and then we will get an odd number which we can reduce with 3. So we can reduce to one number. So that's the solution for question 2.
0 mod 4, 2 mod 4. 2 mod 4 leave तो बचा है.
नहीं सारे इवन के लिए हो गया, सारे ऑड के लिए हो गया, पर ग्रेटर देन 6 के लिए.
तो उसने
So of course we see कि ये वाला जो हमारा है algorithm, it won't work if we have like 3l equals 4l minus 1, then you'll be stuck or something like that. So हम यहाँ से easily देख सकते हैं कि n equal to 6 तो we already saw it wasn't working, and then you can see that n greater than equal to 8 is sufficiently big so that these terms won't be equal to each other. So yeah, and yeah, n equal to 6 we can bash out the cases that it won't work. And the final answer will be
how can we bash out? Do we have to completely bash the cases, or can
we
not?
can show some smartness here also, of course. Like we can take that the first operation will be 1 3 3 5 or 5 1 because the other case will be symmetric, and then we can do some case work here. Like this.
Whichever way we can reach to even numbers, we'll bash out all the cases. All right.
Yeah. And then the final answer will be we can do n equal to odd greater than 3, and we can do n equal to even greater than equal to 8, and that's it.
Yeah, yeah.
Something.
हाँ हाँ ठीक